Today's topic is motion under gravity. We will solve some numerical problem based on the concept of motion under gravity. So very important concept of one-dimensional motion, and try to understand it. I will try my level best to make you understand the things going to happen within this uh, topic, motion under gravity. Okay, so today I will solve few numerical problems. Number one, points P, Q, R are in a vertical line such that this is a vertical line, points P, this may be Q, this may be R, PQR, and these points are such that PQ equal to QR, PQ equal to QR, or you may consider this one as at the bottom also. So this is Q, PQ, and this is R. Okay, consider this one as Q and this one as R, just before it hits the ground. So PQ is equal to QR. This is the scenario. A ball at P is allowed to fall freely. What is the ratio of the times of descents? Now you are allowing a ball to fall freely. I mean U0. So U0, you have dropped a ball, you are allowing a ball to fall freely. Now from P, now you have to find the ratio of time taken by the ball to cover the distance PQ and the distance QR. The first thing comes in mind, the time taken by the ball to cover distance PQ, will it be same to the time taken by the ball to cover the distance QR? Do you think will it be same? Yeah? Shayanika, yeah, Sainika. Okay. Atrai, yeah, time taken by the ball to cover distance PQ. Will it be equal to the time taken by the ball to cover the distance QR? These times may not be same, or may be same. May not be same, or may be same. May be same. So if it takes 2 seconds in covering distance PQ, the remaining half distance, will it take more than 2 seconds or less than 2 seconds? Less than 2 seconds. So see, this height, so PQ, if you consider this height as X, or if you consider this whole height as H, then this will be H by 2, this will be H by 2. So or you may consider X only, so this is X and this one is X only. So then you can write X is equal to from P to Q. If T1 with the time taken by the ball to cover a height PQ, to cover distance PQ, So then X is equal to UT T plus half GT1 square, UT plus half T square. And if you want to find this distance QR, which is equal to X only, but before that you have to find the velocity of the ball at the end of time T1 second. So velocity, when the ball reaches this point, its velocity becomes, so velocity of ball at the end of T1 second. So then this is equal to, if it is suppose V, then V is equal to U plus AT, T is T1 only, GT1. Now for this journey, this will be taken as initial velocity. and then the height x is equal to ut. So this is your u. So this gt1 is the u only. gt1 ut, time taken is now t2. This part is t2. This time is t1. This time is t2. So ut plus half g t2 square. Half g t2 square. Now you can equate these two equations. 1, 2. So from 1 and 2, you can write, yeah, x. So these two are equal. So half g t1 square is equal to g t1 t2 plus half g t2 square. Just take it this side, and then half g t1 square minus t2 square, okay, is equal to g t1 t2. Cancel g. Now half, and then you have to find the ratio of the time t1 by t2. How will you find that ratio? Yeah, ratio of time, that is t1 by t2. So how can you find that ratio? This is 2. So t1 square minus t2 square is how much? This is 2 times of t1 t2. So then t1 square minus 2 t1 t2, yeah, minus t2 square is equal to 0. Can you solve it? 2 t1 t2. So how will you find t2? Yeah, tell me. How will you find t1 by t2? t1 by t2, that ratio. So you can solve it by some other way also. I think this process becomes little bit complicated, because this is ut plus half g t2 square. So anybody can find it? Yeah, tell me. Can anybody find it? Hello? Hello? No response. Suryasis. Yeah. So this is your equation. So how will you find t1 by t2? That ratio you have to find. So is there any other way to find? So this is t1. Okay, the ball takes t1 time from P to Q and t2 time from Q to R. This time interval is t1, this time interval is t2. So you have to find the ratio. Yeah, t1 is to t2 or t2 is to t1, whatever you can find, whatever. So the best way to find is t1 plus t2 is the total time. So the one equation may also be written as 2x is equal to ut plus half gt square. Yeah, this 2x is equal to half g t1 plus t2 square. So from here it is t1 plus t2 is 4x by g square, and you have somewhere t1 minus t2 square, t1 square minus t2 square. So from this relation you can substitute the value. So can I substitute here? So this is T1 plus T2 into T1 minus T2 is equal to T1 T2 from this relation, 2 T1 T2. So just divide one of the equation. So what you get? T1 plus T2 whole square, T1 plus T2. Now the answer is 1 is to root 2 minus 1. 1 is to root 2 minus 1. Yeah, yeah. So from here can you find it? From here you can find it. So T1 plus T2 square is given to you. That is, if you find T1 plus T2, then it is 2 under root x by g. And if you put the value of T1 plus T2 here, yeah, 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 here, yeah, equation 1 and equation 3, yeah, so then it will be easy, so, yeah, we should not take equation 2, okay, if we have taken, no problem, so just divide it, equation 3 divided by equation 1, 3 divided by 1, so this is 2x, and this is x, and this side it is half g T1 plus T2 square whole divided by half g T1 square. Half g T1 square. Am I right? Cancel it. You can cancel it. So then this side is 2 and here it is T1 plus T2 by T1 square. Take a common square because denominator is also square, numerator is also square. So can I write this one as like this? Okay, now take the square root. The square root is root 2. This is T1 by T1 plus T2 by T1. Okay, the square root you have already taken. That's why it is root 2. Now this is 1. So root 2 minus 1 is nothing but T2 by T1. If you want to take T1 by T2, then it will be 1 is to root 2 minus 1. 1 is to root 2 minus 1. So you need not to take. Yeah, bracket. Bracket means this. Okay. So 1 is to root 2 minus 1. This is the ratio. Ratio of time of descent from P to Q and then from Q to R. So this way you can find the ratio of the time. Obviously, this time is root 2 minus 1. That is less than 1 second. Root 2 is 1.414 second minus 1. So 0.414 second. So this time will be smaller. T2 is smaller than T1. Okay. Now take the snapshot. I will rub the board and I will do the next problem. Yeah. Taken. Yeah. Have you taken? Okay. Now I can do the next problem. More interesting than this. This problem is balloon ascending and descending. So question number 2. So question number 2 is A ball is released from the top of a tower of height h meter. Here is a tower of height h meter, and this ball you have released with u0. Released means you have dropped it with a initial velocity 0. So from rest, a ball is released from the top of a tower of height h meter. It takes t seconds to reach the ground. If it takes t seconds to reach the ground, then you have to find the height covered. I mean, what is the position of the ball in t by 3 seconds. So if t be the time taken by the ball to reach the ground, total time is t. So total time t is equal to t to reach the ground. To reach the ground. Okay. Then you have to find, if t is t by 3, then what will be the position of the ball? Then if t is equal to t by 3, then find the position of the ball. Find the position of the ball. Means from ground or from top. So this is the tower of height h. A ball is released from the top of the tower of height h, and ball takes total t second to reach the ground. Now what will be the answer? So what's your answer? Oh, let me see the another answer. Answer from other student. Anybody else? Shainika. Yeah? What's your answer? So the correct answer is 8h by 9. Why it is 8h by 9? So you have to find the position of the ball. Suppose the ball reaches at this position. So in time interval t by 3 seconds. So then this height, if you consider this one as x or y, whatever, you may consider y also. Y. Then y is equal to ut plus half gt square. So half g t square. T square means half g, t is t by 3. So this is half g t square by 9. Now position of ball from the ground, if you want to find from the ground, now you can replace t. How will you replace t? Then h is equal to, the second equation is h is equal to ut. So u is 0. Total time taken by the ball to reach the ground is capital T, ut plus half g t square. So then h is equal to half gt square. So from here you can find t square. This is 2h by 9, 2h by g, this g, 2h by g. And now put the value of t square here. So from this equation, y equals to half g t square, which is 2h by 9 only, by 2h by g into 9, 2h by g, and then this 9. Okay, cancel g, g. Now this is 2, 2. So this is h by 9. Therefore, position from the ground, position of ball from the ground, position of ball from the ground is nothing but h minus y. This is h minus y is h by 9. So 9h minus h, 8h by 9. 8 by 9h is the position of ball from the ground. So this will be the correct answer, 8h by 9. Okay, take the snapshot. This one is page number 2. Now I will solve the third question. Yeah, take it quickly. Okay, now we are doing, a ball is dropped from the roof of a tower of height h. A ball is dropped from the roof of a tower of height h. Now I am making a tower of height h, and suppose this ball is dropped from the roof of the tower of height h, u0. The total distance covered by it in the last second of its motion is equal to distance covered by the ball in first 3 seconds. So the condition is total distance covered by the ball in the last second is equal to distance covered in first 3 seconds. Distance covered in first 3 seconds. First 3 seconds. This is the condition. Then you have to find the height of the tower. What is the value of h? You have to find the value of h. Take g is equal to 10 meter per second square. The condition is take g is equal to 10 meter per second square, and then you have to find h. Yeah, you got my question? A ball is dropped from the top of a tower, released from the top of a tower, and the distance covered by the ball in the last second is equal to the distance covered by the ball in first 3 seconds. First 3 seconds. Then what is the height of the tower? This is the question. Now if I ask you, the ball covers a distance, suppose y or y1 in the first 3 seconds. So if we take t is equal to 3 seconds, then s you are taking y1. And acceleration due to gravity, okay, a is equal to plus g. Then use the relation h is equal to ut plus half it square. So y1 is equal to, yeah, y1 is equal to half u is 0, so half g t square, 3 square. So this is 9 by 2g. Now if I ask you what is the distance covered by the ball in the last second. So distance covered by the ball in the last second, that is t is equal to 1 second. So before, suppose this distance is y2. And then this time will be t minus 1, and this total time is t. If you consider total time t, then what is the velocity of the ball at the end of t minus 1 second? So that velocity you can find. So velocity at the end of t minus 1 second is how much? u0 plus a u plus at gt. So this way you are getting the velocity at the end of t minus 1 second. This velocity. And with this velocity, it is going to cover the distance y2 in 1 second. The interval is 1 second. The interval is 1 second. So then y2, should I write y2 is equal to ut. So u is now g t minus 1, ut. So this is u. T will take 1 second. Last second means 1 second. Plus half g t square, 1 square. So in the last second means t is equal to 1 second. So you are taking this scenario. T is equal to 1 second. So then y2, it's how much? G t minus 1 plus half g only. So should I write gt minus g plus g by 2? So it's how much? gt and then minus 2g plus g. So it's minus g by 2. And this is y2. According to question, this y1 is equal to y2. So according to the question, since y1 is equal to y2, so what is y1? y1 is 9 by 2g. And what is y2? It's gt minus g by 2. gt minus g by 2. Now you can, so you have to first find So you can cancel G. Okay. Then this is 9 by 2. So 4.5. Should I write 4.5? And this side is T minus 1 by 2 is 0.5. So the total time taken by the ball to reach the ground is 4.5 plus 0.5 is nothing but 5 seconds. Now in 5 seconds the ball will reach the ground. So the height h is determined, h is equal to ut, u is 0, ut, okay, t is 5 seconds plus half g t square, 5 square. So this is half, take g 10, t square is 25, 25 into 5 how much? 125 meter. So height of the tower is 125 meter. Height of the tower is 125 meter. Okay, written. Okay, take the snapshot. Oh, I should change the paging. It's page number 3. Okay. Huh? Yeah? Fifth line from the bottom. This one. This one. So this y2 is equal to, this distance is equal to ut. So u at the end of t minus 1 second you have calculated. Velocity at the end of t minus 1 second. So should I write at the end of t minus 1? It will be easy for you. Okay. Velocity at the end of t minus 1 second is equal to u0 plus at. A is g only, t is t minus 1. Now this distance is equal to initial velocity, which is gt minus 1 here, into ut, t is 1 second, plus half g t square, again t is 1 second. This interval, last second means 1 second. If the total time is 5 seconds, then this is 4 seconds. This is 5 seconds. Means fifth second means 1 second. Interval is 1 second. 4 to 5. So last second. And then you put t is equal to 1 only. And then after that you have to solve it mathematically. Simple mathematical relation is there. Yeah? Surya says? It's okay? We have, yeah. Take the snapshot. Taken. Okay. Now, question number 4. Question number 4. This question is also very important and interesting also. Question is, a stone is dropped from the balloon at an altitude of 300 meters. Suppose you have a balloon and this balloon is at an altitude of 300 meters. 300 meter h. 300 meter. And a stone is released from this balloon. By any means, suppose you are inside the balloon and you are dropping this stone, or some stone is released by any means. Okay, the stone is released from this height, from the balloon. Now how long will the stone take to reach the ground if the first condition is balloon is ascending with a velocity of 5 meter per second. Ascending means the balloon is moving upward with a velocity 5 meter per second. So if the balloon is ascending, the first condition is how long will the stone take to reach the ground? If it is released from a height of 300 meter, then, and balloon is ascending, means the velocity of balloon is 5 meter per second at this instant, 5 meter per second. Then how much time the stone will take to reach the ground if it is released at a height of 300 meter? This is the question. So then, if I ask you what is the speed of the balloon or velocity of the balloon at the time when it is released, Then, yeah, tell me, that speed will be, or velocity will be, so take it as u. So that u is equal to 5 meter per second. That is the speed of balloon only. The speed of balloon only. If the balloon is, yeah, okay, I will see. So u is equal to 5 meter per second. U is equal to, means for a stone, the initial velocity is in the upward direction. It is in the upward direction. And then a stone will move vertically up, and then it will come back, finally touches the ground. So if I ask you what is the displacement of the stone, displacement is initial and this is final. So displacement is initial to final, that is 300 meter. So displacement h is equal to this height. So this is minus 300 meter. Why I am taking minus and this side plus? Because the initial speed of the stone is in vertically upward direction. And the physical quantity which are in vertically upward direction, we are giving positive sign for them. And the quantity which are in downward direction, we are giving minus sign. Opposite direction, negative sign. So displacement is from this to this. So along vertically downward direction, that's why h is equal to minus 300 meter. Now a is equal to acceleration due to gravity. If you see the initial condition, the stone is going vertically upward. Stone is going vertically upward. So who will report this phenomena? The person standing from the ground, observing from the ground. So what he observes, the stone will first go upward because it has some initial velocity. That is velocity of the balloon, 5 meter per second. So stone will go in upward direction. So the velocity is in upward direction. Since the motion is upward, that's why acceleration is minus g. Acceleration is minus g. What I told you in the very earlier classes, so acceleration due to gravity is always minus g. So if you consider a, that means physical quantity which are in upward direction positive, then the physical quantity which are in downward direction, that should take negative sign. So when you release a stone from some height, then we take h as negative, h as h positive. Everything you can take positive or everything you can take negative. That hardly makes any difference. Everything you can take. So u, g, everything, take it negative or take it positive. So a is equal to minus g and then time t. So time t taken by the ball or the stone to reach the ground, total time is, suppose it is t, that we don't know. You have to find t. So then very simple relation is h is equal to ut plus half gt square. Ut plus half at square or gt square, we will convert it. So put h is equal to minus 300 meter. Then u is plus 5. Then t is, yeah, t only, plus half a is minus z into t square. So this is minus 300 is equal to 5t minus 5t square. Take g is equal to 10 meter per second square, or if you consider g is equal to 9.8, then your answer will be little bit different. Should I take, if g is not given, then you should take 9.8. Okay. Then take everything in the right side. So then 9.8 t square minus 5t minus 300 divided by 2. Okay. It's 4.9. 4.9. Then, okay. So we are taking 10. No problem. So then 10 t square. So this is 5. So then 5t square. Should I write here 5t square? Minus 5t minus 300 is equal to 0. Now cancel t, 5. So t square minus t minus 60 is equal to 0. Now you can find the value of t by using quadratic equation. T is equal to, yeah, minus b plus minus under root b square minus 4ac. C is minus 60 by 2a. So your answer comes to be 1 plus minus, that is 240 plus 1, 241, under root 241 divided by 2. So what is the square root of 241? Approximately, you just tell me approximate value of under root 241. Yeah? The square root of 241. 15.5. Okay, leave the 15.524. 52 you can take by 2. So you just consider the positive value. So 15 plus 1, 16.52. 16.52 by 2. Don't take the negative value because time will never be negative. And then divide it. It's 8.4, 8.26 second. 8.26 second. Total time taken by the stone to reach the ground. But think, if the balloon starts descending with speed 5 meter per second and at that instant you have released the stone, then how much time it will take? Will your answer change or your answer will not change? It will again take the same time. So if the balloon, in first case, the balloon is ascending. Now the balloon is descending. So that we are dealing the case of descending. Okay. Balloon, the first case is A is when the balloon is ascending with 5 meter per second. Now what will happen if the balloon starts descending? So okay, take the snapshot. Taken. I will rub the board. Okay. Now this part I will change a little bit. In the same question, number 4. Now when the balloon starts descending, so the second bit is B. When the balloon is descending with 5 meter per second, then in that scenario U will be taken, yeah, everything we are going to take positive. So downward, or because U is in downward direction, H is also in downward direction. Now the other factors, G is also in downward direction. So we can give positive sign to each quantity or we can give negative sign to each quantity. That hardly makes any difference. You will have the same answer. I can show you. So I am taking 5 meter per second. Then acceleration is plus G. So G time T, suppose T, and H is equal to 300 meter. Everything we have given positive sign. Then use the relation, same relation, H is equal to UT plus half AT square. So half AT square, H is 300, U is 5, T plus half GT square. Okay, 300, 5T plus, it's how much? 5T square. So this is 5T square plus 5T minus 300 is equal to 0. So T square plus T minus 60 is equal to 0. So if you find T, then minus B is 1 only. Yeah, plus 1 minus B plus minus under root B square minus 4AC by 2a. So this is minus 1 plus minus under root 241 by 2. So this is minus 1 plus minus, and this was 15.52 by 2. Now plus 15.52 minus 1. Don't take negative values. So your answer will be 14.52 divided by 2. So finally you are getting 7.26 second. Not same. Difference of 1 second is there. 8 second, 8.26, 7.26. Yeah? Difference is there. This time is less. Not exactly equal to 8.26. The earlier time was 8.26. Now the stone will take only 7.26 second. Now the scenario is balloon is descending downward with u is equal to 5 meter per second, and it was at a height of 300 meter, and then you have dropped the stone. So the time taken by the stone is little bit different. Yeah, this part. They are not same. There lies a difference. But can you tell me what will happen if the balloon was stationary? Balloon remains stationary, and then you have released the stone. So then time taken will be, yeah, the third case. We are dealing the third case. So when balloon was stationary, was at rest, balloon was stationary, neither moving upward nor moving downwards. So in that scenario, the initial velocity is 0. I mean a stone. And then A, G only, T, T only, and then H is 300 meter. Now we have taken everything positive. Or you may give negative sign. That hardly makes any difference. You do it at your home, you will get the same result. Now assigning everything negative and then solve it. Nothing will happen. Because the moment you give negative, that negative will cancel out. That negative will cancel out from both RHS and LHS. So does it make any difference? Yeah? Does it make any difference? No. So in downward motion, you can give everything negative, you can give everything positive sign. No problem. It is up to you. Then U0, AG, T is equal to T, H is equal to 300 meter. Now use the relation again, same H is equal to UT plus half GT square, AT square. So H is 300, UT, U0, this part is 0. Now half G10 into T square, 5. Okay, so T square is 300 by 5. So it's 60. So tell me the square root of 60 approximately. Yeah, approximately 7.82 second. 7.82 second. Approximately square root of 60. You can just see when the balloon is stationary, then if you release the stone at the same instant, then the scenario will be time taken by the stone to reach the ground is 7.82 second. And in first case, when it is ascending, the time taken will be little bit, the first case 8.36, and here it is 7. For first case 8.26, and here it is more than that time. T is equal to 7.82 second. Yeah. First case was when the balloon is ascending with a velocity of 5 meter per second. Second case is when the balloon is descending with a velocity of 5 meter per second. And the third case is when the balloon is stationary. So when the balloon is stationary, then total time taken by the stone to reach the ground is 7.82 second. Yeah, done. So this is page number, page number, page number. Yeah, tell me, 4 or 5. Okay, you just correct it. Numbering is there. Question number 4. Okay. Now we are doing some more interesting problem. One or two problem I can do because I have the enough time. So the scenario is, now the question is, a balloon rising vertically up with uniform velocity 15 meter per second releases the ball taken by the ball to time taken by the ball to hit the ground and total height of the balloon when the ball hits the ground. That I have done. No. This question I was not taking. Okay, so question number 5. Number 5. Number 5 is, question number 5. It's an interesting question, very interesting. I will show you the special. The question is, a balloon starts from the ground with an acceleration 2 meter per second square. So here is your balloon. So it starts with acceleration a is equal to 2 meter per second square. Obviously it will start from rest and with the acceleration 2 meter per second square. After 5 seconds, a stone is released from the balloon. So after 5 seconds, a stone is released from the balloon. Okay. So can you tell me what is the velocity of the balloon after 5 seconds? So when you release the balloon from rest, then after 5 seconds, what will be its velocity? So velocity of balloon after 5 seconds of its release from ground. Okay. So then V is equal to U plus AT, U0. A is 2, don't take G, that is A2 5 seconds. So then V is equal to 10 meter per second. Yeah, 10 meter per second. V is equal to U plus AT. So U is 0, AT, 10 meter per second. Okay. Now if I ask you what is the height of the balloon after 5 seconds, that height you can find. So height attained by the balloon. Height attained by the balloon after 5 seconds. So that height h is equal to, yeah, ut plus half gt square. Yeah, tell me height. So don't take g, this is 2 only. So 2, acceleration is 2, half at square, t is 5. So h is equal to 25 meter. So at that time balloon was at a height of 25 meter from the ground, 25 meter. And at this instant a stone is released from the balloon. Now you are going to release this stone. So, or a ball from the balloon. Now if I ask you what is the initial velocity of the stone, then initial velocity is the velocity of the balloon, which is 10 meter per second at t is equal to 5 seconds. So then initial velocity of the stone, u for stone, u is equal to 10 meter per second, 10 meter per second. So take a positive sign because it is an upward direction. So stone will move first in upward direction and then attain some height, and then after that it will come back and then hits the ground. Now the question is, what is the time taken by the stone to reach the ground after its release and total height attained by the balloon. So you have to find the time taken by the stone to reach the ground. Okay, so A, now once it is released from the balloon, the acceleration of the stone will be different from the acceleration of the balloon. Now the stone starts falling under gravity, and so the acceleration of the stone is equal to acceleration due to gravity. So acceleration due to, so value of g is minus 10 g, okay, so minus 10 meter per second square. So take A is equal to minus z because A is in downward direction, U is in upward direction, and total displacement of the stone. So stone will move like this. So if you find the displacement of the stone, then this is 25 meter. So H is vertically downward, so minus 25 meter. Why I have given plus minus sign? Because here some of the physical quantity is in upward direction and other physical quantity is in downward direction. That's why for upward direction positive, for downward negative. But if all the physical quantity is in downward direction only or in the upward direction only, then assign positive sign or negative sign. So suppose for downward direction we have given for all physical quantity positive sign or negative sign. So H is equal to, so H, okay, I am doing H is equal to minus 25 meter. Now T you have to find time, how much time it will take. So again use the relation H is equal to ut plus half gt square. Okay, so H is minus 25, U is 10, T you have to find half, G is minus 10 into T square. So you have one relation. This is 5, so take it this side. So 5t square minus 10t minus 25 is equal to 0. So then the relation is t square minus 2t minus 5 is equal to 0. So you can find its value by using quadratic equation. The role of quadratic. T square minus, okay, there are several methods. Or t is equal to minus b plus minus under root b square minus 4 ac. So you have studied in class 10 quadratic equation, no? So what is the use of quadratic equation? Just utilize it. So it is 4, 2 plus minus under root. This is 20 plus 20 minus 4. It's how much? 20, 20 plus 4, 24, yes? 24 by 2, no? So t is equal to, yeah, tell me, t equals to, it's 2 root 6. Approximately you can take 5. So you can cancel 2, 2, 2. So 1 plus minus root 6. So taking only positive value. Second. So if you put the value of root 6 also, so root 6 is how much? 2.449. So it's 3.449. Should I write approximately 3.5 second? Approximately 3.45, not 5. 3.45. 3.45 second. 3.45 second. So this much time it will take to reach the ground. Now the question is how much height it will cover. Now during that time interval, now after it the stone has been released, now during that time interval, the height of the stone balloon from the ground, what will be the height of the balloon from the ground? So this time is, it's how much? So in covering 5 meter distance, it will take how much second? So 25 meter distance, 5 second, 5 second, and this 5 second plus 3.45 second. So the total time is, if you find it from ground, the height, then you have to take the total time. So within 5 seconds, balloon will reach at this position, that is covering a distance of 25 meter, and then again it will take time 3.45 seconds. So it will cover how much distance? So the total time you just take. So total time is 5 plus 3.45. This is 8.45 seconds. Is the total time. And if you want to find the height from the ground, then take t is equal to 8.45 seconds, and then use the relation h is equal to ut plus half gt square. So ut part is 0. Ut is 0 plus half. Don't take g, because balloon is ascending with its own acceleration, 2 meter per second square. So into 2 half a t square, 8.45 square. This will directly give you the value of h from the ground. So within 8.45 seconds, the balloon will be at a height of, so you can cancel this 2 with this 2, square it, 8.45 into 8.45. Yeah, will it be 71.4? Just see, 71.4 meter from ground. From ground it will be at a height of 71.4 meter. Okay, from ground. So this is the height of balloon from the ground. Height of balloon from the ground. So this type of question is highly conceptual and asked in different comparative examinations as well as in your board examination or your class 11 PT1, PT2 half yearly annual examinations. So get ready for preparing this types of question. Okay, so today I will finish this motion under gravity portion, and from tomorrow onwards I want to start the new chapter